Okay. All right, let's do this. Hopefully, y'all did well on the exam. We got a brief lecture on file I/O, getting ready for programming task 6. This won't be too much. 1 hour getting you ready for this task. It's all about reading CSV files. Let's jump into it. We got a lot to cover in an hour, so let's do it. Morning, Jeshwant. Save. Open. Full screen. How does opening a PDF take more than a millisecond? So this is what we want to do, is read files, and just a brief recap of what files are. This is 115 concept, so there's nothing new in the theory, but I don't know how much they talk about why we even use files. It seems like even a silly question to even ask. We use files all the time, even if you're not a programmer. But why do we use files? What do they do? And the answer is persistent storage. Persistent storage is why we use files. Everything that we talk about in our traces that you just did for the midterm, everything in the stack and the heap, all of that is in RAM, and that's temporary storage. As soon as your program ends, everything's removed from the stack, everything is removed from the heap, and everything disappears. So if you want information that lasts after your program ends and exists before your program starts, that persistent storage, we're going to have to save that information on the hard drive, and that's where we go to disk. That's where we save our files. So that's why persistent storage, that's the big thing. Storage that's going to persist even through a device restart. Your files are still going to be there, but everything in memory is wiped, constantly, all the time. So that's why we use files, persistent storage. So that's my quick recap of why we use files. It doesn't take long. And let's just jump into reading files in Java. This is under the assumption that you've already read files in Python. If you haven't, I'm still going to cover everything. I'm going to start from square one, but I am going to go through it fairly quickly because I assume you already know the concept of reading files. So let's go through this example and talk about what we're doing here and how to read these files. So a few things. One, this is the simplest way to read files in Java. Actually, I have a slide on that later. I'll talk about it more later. This is the simplest way to read files in Java that I've found, at least, using the standard library. So I like using this one in 116 so we don't get too bogged down with iterators and all that, a lot of other stuff. So Java can't just read a string as a file name. Like Python, you just do with open some string as your file, and then you have your file open, and that's it. That's all you do. And the intermediate steps are hidden. They're all in that open method. With Java, we do have to manually do a little bit of the extra work. Not too much, but one little thing here. We have to convert a string into a path to a file on disk, navigating our directory structure. For that, we use the paths object, which has a static method named get. We're going to call that method with our string representing our file, and it's going to convert that string into a path. And that path object is what we need for the next method call, this read all lines, which is a static method in the files object, the files class. Files class, we don't need an object because it's static. The files class has a static method named read all lines, which takes a path, and then we're going to feed it that path that we just created with our string. So we're going to convert our string to a path, feed our path into read all lines, and that's going to give us all of the lines of the file. Each line break is going to be a separation of the data, and it's going to give us all that data as strings. So we're going to get a data structure of strings. And this is where I want to make my note of, this is the simplest way to read files in Java. It's not always the best way. Pretty much any tutorial you look up, anything you search to read files in Java, it's not going to do it this way. It was actually hard to even find this method. I don't know if that's still the case. I assume it is. But everything will tell you to use a buffered reader. And if you look at the code, it's kind of a jumbled mess of like, not too much, but like 5 lines of code, creating the buffered reader and the buffered input, and then using an iterator to go through all of the data. That's the better way to read a file. If you have a very large file, you want to buffer your inputs. What we're doing here is reading the entire contents of the file all in one go and loading the entire file into memory, which is fine for what we're doing in 116. Even when we have megabytes of data, that's fine. It's like we have billions of bytes. We're fine. But if you have larger files, and especially if you have files that are getting into the gigabyte range, or even if you have a file that's larger than your memory, more than the memory that you have in your machine, you're going to have to buffer the input, which means you're reading a small piece of the file, loading a small piece of the file into memory, processing that piece of information, and then discarding it. So you're only loading a portion of the file into memory at any given time. And that's why that's the recommended way, as long as you're reading large files. But then it just kind of gets swept up. And if you're reading a file in Java, always buffer your inputs, or really any programming language. Always buffer your inputs. But if your files are small, like, don't get too hung up on it. But if you do have large files in the future, just know that read all lines isn't going to do it for you. So with that disclaimer out of the way, let's move on. So read all lines returns a list, which is an object that implements the list interface, something that we'll talk about in polymorphism on Thursday, what an interface is. But if you don't want to worry about what a list is and interfaces and all that stuff, you can just feed that list into an array list constructor and now work with an array list directly. So if you don't want to learn another data structure, list has all the same methods as an array list. It actually wouldn't be that big of a deal. But just so I don't have to, in the homework, say return a list and then have students returning array lists and then getting errors. And actually that wouldn't give an error, would it? But it would cause confusion though. Just so we don't have that confusion, I'm going to stick with array list. I'm actually going to do this again later in this lecture. We're going to have an array that we're going to turn into an array list. Just so we're only dealing with one sequential data structure that has random access. Is the simplest way to say that. Because we do have linked lists. There was a big reason why we learned linked lists. There's no reason to also learn lists. It actually is. I don't have to get into details. If you don't want to think about a list, feed it into the array list constructor and then work with that array list. If you want to work with a list and you want to learn about interfaces and stuff, that's fine too. Knock yourself out. But if I have a method, like the methods for task 6 ask you to return array lists, you will have to feed those into the array list constructor eventually. You'll eventually have to create an array list to return. Okay, there's one big problem though with this code, and that's it. Like that's file I/O. That's reading files. I say I/O, but we're not gonna output files. We're not gonna write to files in 116. And so this is it. This is reading files. But there's one big problem with this code is it doesn't compile. This doesn't run. I pull one over on you. It doesn't run. This is broken. I didn't actually pull one over on you. I just don't want to show you the whole code all in one go because it's a bunch. But let's talk about it now. So the problem here is that we don't know if this file actually exists. And if this file doesn't exist, this code is going to break. This code's going to say, oh, file's not found, and it's going to throw an exception. Or saying another way, this code is dangerous. This is dangerous code because this file might not exist, and we cannot possibly know if this file does exist. There's no way for us to know if this file exists. I usually go on a big rant. Morning, Dave. I usually go on a big rant here and explain the whole thing. I'll try to keep it briefer than I usually do right here. But it's an important concept nonetheless, is that we cannot know that that file exists. So there is, in Java, there's a method that I think it's just called it exists. Like you can check, you can feed it a path and say, does this file exist? Is there a file here at this path? And it'll return a Boolean like you would expect, and check. If the file exists, it returns true. If it doesn't exist, it returns false. So what you could do is say, if the file exists, then do this code. Seems safe, seems fine. The code is only executed if the file exists. The problem is there's a brief window there in between the time you check if the file exists and the time you actually open the file, and that window, albeit extremely small, is finite, and there's a small chance I shouldn't even say small, there's a chance that another program running on the device is going to delete that file in that little small window. And if it does, if that file doesn't exist by the time you open it, in between the time you checked if it exists and the time you open it, it was deleted, you're still going to get an exception. So there's no possible way for us to actually know if that file exists. We can't tell the operating system, hey, I'm going to reserve this file, don't let anybody touch it because I'm about to open it. We just don't have that mechanism. It doesn't exist. And since we're working with disk, every program on the device can all access disk simultaneously. So we have this issue, whereas we didn't have it before. When we're working with our own data structures, well, that's in memory, and memory is isolated for our program. Nobody else is allowed to touch it. So we can guarantee things about anything in memory, but we can't guarantee anything about what's on disk. So this is dangerous code, and we just don't have control. Sometimes we will open a file that doesn't exist, and the actual concern, like that window's really small, you'll be like, I'll take my chances, whatever. The issue is that sometimes there are programs running on your device that react to your check if the file exists. It'll see that another program looked at that file, and in reaction to it, it'll go do something. Now, hopefully your programs aren't just deleting files every time you look at a file, but it can happen, and it actually does happen. I said I'll keep it brief. I'll cap it there. But it does happen. It is an actual thing that in reaction to the check, it'll delete the file. So there's no way for us to actually know, and it is something that actually does happen. It's not just a very small chance thing. Okay, and then if that happens, we're going to get an exception that's thrown. And we've been seeing these all semester, but we haven't shown a spotlight on them and called them by name. But whenever an exception is thrown that isn't handled or caught, as we're going to see soon, the program crashes. And we've seen these. This is all of your favorites. Null pointer exception. This one we've seen quite a bit. Index out of bounds, some of you may have seen. It's the way we use loops, it's a little bit hard to get this one, but definitely not impossible. Some of you have definitely seen this one. Stack Overflow error. This isn't an exception, but it can't be caught. It will crash your program no matter what, but it is still kind of in the same territory. It's an error instead of an exception, but still same idea. It's going to be thrown, and once it's thrown, everything's done for. So these will crash the program, and this is what you see on your stack traces. When your program crashes, you'll see the exception that was thrown, and then all of the stack frames that were on the stack, along with the line number where they were executing at the point of the crash. So you get your whole stack trace. That's all the red text that's printed to the screen when your program crashes. It gives you tons of useful information about what exactly was happening when that exception was thrown. So we do have another option, though. We don't just have to let our programs crash. What we can do is catch the exception. So let's try that. Let's rewrite our code and catch this exception. Now what this is going to do is we're going to use a try catch block. We're going to try to run the risky code. And if an exception is thrown, we're going to catch it in the catch block. So if the file doesn't exist when this code executes, we're going to get an IO exception thrown. That's what this code is going to throw if the file doesn't exist. An IO exception that says file not found or whatever. So if we're running this code and an IO exception is thrown, we're going to stop everything that's happening in that code block. In the try block, we're going to stop. As soon as the exception is thrown, everything just comes to a grinding halt we stop everything, and we jump to the catch block and say, okay, this is what we're doing if we get an IO exception thrown from the try block. We're going to move to the catch block of the IO exception and then run this code instead. So instead of just saying, run this code, it might crash the program, yeah, whatever, it might crash. Instead, we're going to say, okay, try to run this code, and if it would crash, do this instead. So now if the file doesn't exist, we're just returning an empty array list. If the file does exist, we're returning all the contents of that file as an array list of strings, where the strings are each of the lines of the file. Now this code compiles, it runs, everything's fine with this code, now that we have the try catch block. Because Java will take it seriously. Java says you have no possible way of knowing that that file actually exists, so it's going to say you can't run this code unless you wrap this in a try catch block, or what some students will do, please don't be this student, is add right here throws IO exception. Don't do that. I'm not going to show you the syntax for that. I don't even like mentioning it in lecture. And then every time somebody has that, I say, I know you didn't get that from me. I know you didn't get that from watching lecture. You got that from somewhere else, and you need to start writing your own code. Because what they do is they get the error and they tell IntelliJ to fix it, and the first suggestion on IntelliJ is to do that. So I know they didn't write their own code when they did. They just said, IDE, do my homework for me. So don't be that person. Do your own homework, write your own code, use a try catch block. And if you do the other one, it crashes in Autolab. That's how I always know about it, because they're in office hours or posted on Piazza, why it doesn't work. And they basically turn themselves in. Don't do it. Write your own code. And you won't ever have to worry about that one. All right. So we try to run the code. If it throws an exception, stop execution in the try block, jump to the catch block, and run the code in the catch block. That's catching an exception. That's what we're doing. I got a little ahead of my slides here. So if, and you can have multiple catch blocks. The only exception we're going to catch in 116 is the IO exception for a file not found. But if we had code that was expected to throw multiple different types of exceptions and different things, like if you want to catch a divide by zero exception, for example, you can have multiple catch blocks, and then you're going to jump to the catch block matching the exception type that was thrown. And if you have an exception that was thrown and the type of that exception doesn't match any of your catch blocks, so if this throws a divide by zero error, for example, I don't have a catch block for that, so it's still going to crash the program. But I am catching IO exceptions, so IO exceptions aren't going to crash my program. So we're going to handle the error gracefully. IO exceptions thrown, return an empty array list. I'm done with the course if I finished all the tests in the midterm, right? Yeah. Well, midterms aren't graded yet. If you're confident, if you're absolutely sure you got the midterm right, then yeah. But so once midterm grades are released, then you'll know for sure. Why do we catch it instead of using the exists method to prevent the error altogether? Let's explain that. But why male models? Because there's a window in between checking if it exists and reading the file. There's some finite amount of time in between those two method calls, and the file can be deleted in between those two method calls. There is a chance that the file is deleted, so we can't guarantee. Even if, some finite amount of time in the past, we know that file exists, that doesn't mean it's going to exist by the time we're reading it. Might seem unlikely, but there are situations where that it does actually happen on a regular basis. Yeah, and this, so I was trying to keep that one brief because I usually go on for way too long in lecture explaining that, but maybe I should just go and explain it a lot more. I'll give one example on this because I do like talking about it. That's my problem with it. I had a student had issues with their IntelliJ. Every time they wrote code, their code would be deleted. Like they literally type a line and the line would just disappear. And they went to the TAs. No TAs could figure it out. They came to me, and I was staring at it for a long time, trying to figure out what the hell was happening. We finally figured it out. It took a while, but figured out that they were running OneDrive. They had OneDrive on their machine, and their OneDrive was syncing up with their IntelliJ projects directory. They were actually saving their projects in their downloads directory, which caused the issue. And OneDrive was monitoring the downloads directory, and every time there was a change to the file, OneDrive would detect the change and then overwrite the file and say, hey, you're out of sync with what we have on the server, and refresh based on what's on the server. Why OneDrive does it that way instead of syncing from local to the server, I don't know. Call it Microsoft and complain to them. But that's what was happening. So there are programs that will monitor your files, and in reaction to you checking if the file exists, might do something with that file. Hopefully it's not just straight up deleting every file you look at, but that could happen. That there might be a program like OneDrive that's monitoring that directory, and then when you check, does this file exist, it might wake up OneDrive and say, oh, wait a minute, no, that file doesn't exist on the server, so we got to delete that file. Thanks for giving me the heads up, because I was monitoring that file and it like kicked in one of its checks and then deleted the file. Like, it's something that can happen. It does come up. So we can't guarantee that the file exists, because OneDrive might be there just to ruin our day. That student was very relieved when we finally found the issue. That was a tough one. All right. So what we want to do in this course, the files that we're going to be reading are CSV files, comma separated values. I'm pretty sure you still do this in 115 every semester. So I don't have to go over exactly what CSV is, but, well, I guess I can in 1 second. It's CSV, comma separated values. Each line of the file are values separated by commas. That's it. And to read these CSV files, each line we're going to split on commas to be able to separate those values into a data structure where each value in the data structure is the value in that line of the file. So we're going to split on commas, which means every time there's a comma, we're going to treat that as the start of a new value. Now, this isn't the right way to parse CSV. This is one thing I don't like about this lecture. I have so many of these disclaimers, like, here's a list, but we're not going to use list. Here's array, we're not going to use array, which is coming up. And this isn't the way we actually parse CSV. It's not the right way to parse CSV. You don't just split on commas. So out there in the real world, if I see any of you just splitting on commas on real world data, I'm going to get mad, but I'm going to get mad at myself for showing you the wrong way. The proper way to parse CSV is a little more complicated. The issue is, what if in your data that you're storing in CSV format, if the data itself contains a comma, what do you do? Well, our code, the way we're going to do it, just splitting on commas, it's going to break. It's going to split that piece of data in half. It's going to treat that one value as two separate values, and everything's going to break. The CSV way, the actual format says if your data contains a comma, we're going to surround that data in double quotes. So if you have comma, double quote, and then any amount of text, and then another double quote, and then another comma, that everything in between those two quotes should be treated as a single value. So that's the way we can have data that contains commas. And then the question immediately becomes, what if your data contains commas and double quotes? Well, now we have to escape the double quotes, so we're going to do / double quote instead of just double quote. So we're going to look for all those little things to be able to remove them, removing the double quote surrounding data, but not a double quote that's not right next to a comma, and having a matching double quote. Just a lot of little things. It's something that you could definitely handle. Like, you could write a CSV parser in 116. I could have that as an assignment. But we don't have room in the current project for that. I mean, I don't know, maybe it could be on task. I think task 6 is big enough. There's enough think you'll all agree by the time you're done with task 6 that task 6 is enough work as it is without adding proper CSV parsing. And there's no CSV parsing library built into Java like there is in Python. In Python, you just import CSV, CSV dot, do it for me. Not so much in Java. There's no CSV parser built in, which means we needed an external CSV parsing library, and all the external CSV parsing libraries I've looked into have really awkward syntax, really kind of way more painful to use than they should be. So regrettably, I'm just going to show you the dot split, and then we can move on. This is going to be fine for 116 because all the data I give you, the movies, the movie ratings, and the songs, all those 3 files are going to be completely sanitized, meaning I went through all the data. I mean, I didn't go through it manually. There's way too much data there. But I wrote some code and ran a bunch of scripts and stuff to make sure that those cases never come up. So we can't have any movies or songs that have commas in the titles. They've all been removed. And double quotes. We're not messing with double quotes. It's all sanitized, so you don't have to worry about this. So splitting on commas is going to work fine. So splitting on commas, we're going to take a string. The string class has a non-static method named split that takes another string and then splits that string on commas. So if I have the string A, B, C, and I do that string dot split on commas, I'm going to get an array with the values A, B, and C at index 0, 1, and 2. And yes, I said array. So again, just like with list, you can just use an array. If you want to mess around with plain old arrays, that's perfectly fine. Have fun with it. Arrays work with the same syntax as lists in Python, so it's not a big departure. It's definitely something I could put on the homework and say we're going to use arrays here and return an array and all that stuff. But it's one of those things that's just another thing, and it's not related to any of the learning objectives of CSE116, so I'd rather just pretend it doesn't exist a little bit. Just so we have one less thing to be confusing. But if you're like, nah, I got this, I want to use arrays, go for it. You can use arrays. You don't have to do this. But if you don't want to think about it, if you don't want one more thing to think about, because, I mean, you got enough to think about doing 116 in 6 weeks. If you don't want one more thing to think about, we'll use this chunk of code here. We're going to use the ArrayList constructor and feed the array into the ArrayList constructor, just like we did with the list, except this constructor can't take an array, so we have to turn the array into a list using our good old friend arrays.asList. That's going to convert the array to a list, and then you feed the list into the ArrayList constructor, and now you have an array list, and you have a nice, comfy, cozy data structure that we've been using all semester. You don't have to think about arrays or lists at all. So if you don't want to think about arrays, I recommend just doing this, stuff it all into an array list, and then just don't think about it. Don't worry about the other data structures. Array list, hash map, linked list, trees, graphs. Those are the only 5 data structures we need to think about in 116. And some of the information in the CSV files, so CSVs are strictly strings. It's only strings. But some of the data is going to be numeric. It's going to be either doubles or ints. For our purposes, it's going to be ratings, which are ints from 1 to 5. So we need to convert a string to an int, and here's the syntax for that. I don't have a ton to say about it. That's just, there's the syntax. In the example I'm about to code, we're going to do some live coding in this lecture. I'll use double.parseDouble. But for the homework, it's going to be integer.parseInt to take that rating and convert it into a numeric value, into an int. So these are the ways we'll convert strings to numbers. These will only work if the number is well-formed. So as long as we have a well-formed double or a well-formed int, meaning that the string actually does represent a numeric value, then it's going to convert it just fine. But if it doesn't, so for example, if we do integer.parseInt and then the string FOUR, we're going to get an exception thrown. It's going to be a number format exception. If you ever see a number format exception while you're doing task 6, that means you're trying to convert something into an int that wasn't a rating. Because, well, that's the only case that you should be using these methods. That wasn't a rating, so you got something off somewhere. For some reason, you're just not, you're getting a string that's not a rating that you're trying to convert into an int. And all of the data is well formed, so as long as you're in the right column, as long as you're pulling the right data from the right location, it's going to be a well-formed int. I don't have any surprises in the data where it's like, oh, it was actually FOUR instead of the number 4 for the rating, for that one rating halfway through the songs.csv. I'm not doing that to you, so they will all be well-formed. That means you're pulling the data from the wrong spot. Okay, live coding. We did that in half an hour. We're doing good. We got some live coding time. Okay. And I have a bunch of code already written. Oh, it is a lot. A bunch of code already written, and this is the code that we want to write. So here's the method that we just talked about in lecture. We got this read file method that's going to take a file name as a string and return an array list of strings. And by the way, you can just use this method in your code as well. So that's fair game. I mean, we just saw it in the slides. It was covered in lecture. It's in the examples repo. Fair game to just use this method. It's fine. The method that we want to write is this load countries method that's going to take a file name and return a hash map of strings to an array list of cities. Ooh, yeah. So we're going to read a CSV file in this format. Every line is going to have these values: the country, which is actually a country code, a 2-character country code, a city name, a region name, the population of that city as an int, the latitude and longitude of that city as doubles, so the location of the city. This is all the information that we'll have in the file, and if we meander on up to data, we can see the cities.csv is a whole bunch of data in the format that we just saw, that we just described. It's going to have a header line. Important to note, does your data have a header line or not? And then a lot of cities, and this is going to be a lot of information. And we have 40, well, minus the header line, 47,977 cities in this data. So we have a lot of data, and this is why we would do file I/O, is when we have lots of data. If we had 2 cities, hell, we could just hard code those 2 cities into our code and be done with it. But when we have almost 48,000 cities, well, now I want software to do the work for me. It's really why we write code at all. If we only had 2 cities, we'll do things on paper and a calculator. Who cares? 48,000 cities. I want software. For your homework, it's going to be this songs.csv. It has a whole bunch of songs with ratings. So song ID, artist title, reviewer ID, and then rating. And then we can have the songs showing up multiple times in here. And I don't think this is the one in the homework, is it? I don't even put it in there. I should probably explain that. So your songs.csv, I put them nice and bold here. So you can download the songs.csv. Kind of curious how either of these going to give me line numbers. Let's do it this way. It's not the... I'll show it just how you'll do it. So you go to data, new file, songs.csv. I'll paste them. 1217, maybe it was the same file. 1217. Yeah, it is the same file that I have hosted. So 1217 ratings. I don't know how many songs in here, but a whole bunch of data. provided by students from a prior semester. I had them all vote on their favorite songs, and whatever was on the radio that day is mostly what they vote for. That and meme songs. But you can see what prior students of the class liked for their ratings. And then movies.csv, this is the one that's preloaded in the repo. We have the title of a movie and then a comma-separated cast list, which can be any number of cast members. And this is 4575, so over 4,500 movies in here. And then movie ratings, title of the movie, reviewer ID, reviewer, the rating for that reviewer. And this has a whole bunch of ratings. So almost 25,000 ratings for movies. And this movie data, this is real data that I pulled from... Did I not have that in the repo? Ugh. I should have that in the repo. I should have my sources in the repo. Let's see. I thought I had it. I usually put a text file right next to my data. Oh, you know what? I have it. I have it in the... Yeah, I have it right here. That's why I don't. And then it's public domain, so I didn't have to reference it in the repo. I usually put it in the repo also, though. The songs that was generated by students, so the source is UB, I guess. And then movies and movie ratings through my app and students in 116. And then movies and movie ratings are both from this publicly available data set. All right, but we're worried about cities.csv right here. So we have all these cities, and what I like to do when I'm writing code that's going to parse a city, I'm going to grab a line. So while we're over here, I'm going to grab a line from this file for when we do... Close all this stuff. For when we do write this code. I'm just going to keep that in my clipboard. And then we have two classes. So we have a city class. We have to return array lists of cities. So I have a city class which captures all of that information from a line in the file. The city's name, region, country, population, and location, where location is a location object. And we have getters for all of our values, and a toString constructor which initializes all of our values. So there's no real functionality of this class. It is basically a container for these values. I'm not doing anything fancy with it. The toString is the fanciest thing. And then same with location. Location is two doubles, latitude and longitude. Getters and they no setters, only set through the constructor. Then the last file here, tests. When we have a full week and we're not under the time pressure of summer, I like to write the tests live as well. I think even in the 11 p.m. lecture, I'm not going to write these live just because I won't have time. But I have a few methods here. So I want to test, given a file name, given a file, I want to call my load countries method. That's the method we're going to write. And I want to check if it returned everything that I expect. So what this method should return is a hash map of strings where each string is a country code, and that maps to an array list of all the cities in that country. So that's what I want to return. Basically just reading all of the data and getting all the data from a file into a data structure. That's my goal here, which is the goal for all the methods in test 6. Except you'll return just array lists of songs and array lists of movies. That's what you'll be returning. So I'm going to call load countries. I'm going to create my expected hash map, which has all of the information as expected from the file that I'm using to test. And then I'm going to call this compare country hash maps, which is going to take the two hash maps, my expected and my actual, and go through and make sure those two hash maps are do have all of the same values in them. And to do this, when we're comparing two data structures, I want to first check if they're the same size. If they're not the same size, we're done. Then I'm going through my expected and checking all the keys to make sure that the one that I'm testing, has all of the keys that I expect. If it does have the key, I can pull the country, the array list of cities for each of them. And I'm going to go through those cities, those array lists, and check kind of the same thing. Check the size, and then go through index by index. For this method, I'm going to say that the order does matter, and the order does have to be exactly the way it appears in the file. And then call compare cities, another helper method on each of those cities, to make sure that each city has everything that it expects. This is what I recommend for all the homeworks. I see a lot of students not using the. This is a tough one to say because anyone showing up to lecture might be doing it the way it's expected. But just in case, using the utility methods. When you write the utility method, the idea is that you'll use that utility method in your tests. And I have a lot of office hour visits and a lot of Piazza questions that are a direct result of not using the utility method, issues that would never exist if they used the utility method as expected. For example, forgetting to check one of the values in a city in this example. Well, I can't make that mistake because I'm using my compare cities utility method to whenever I need to compare two cities. So I'm never going to forget to check the population of a city because it's in my helper method. The first time this comes up is in task 2 with the reviewer creating a rating a song, and then not checking the reviewer ID of that rating. That's one of the very common question in office hours. But if you're using the compare ratings utility method, you literally cannot forget to do that because it's in the utility method. And then cascades through each of the homeworks each time somebody doesn't, like task 3, not comparing the linked lists using the compare linked lists of ratings method. And then, you're not checking all the ratings. It just keeps compounding. Use your utility methods. It's literally the way this homework's structured to prevent some common issues and show you some good practice when you're writing your tests. Anyway, that's what we're doing here. We have 2 utility methods. And then once you have a utility method, and I think this is where the hang up is with some students, is they don't really know how to use it properly. So when you're using a utility method like that compares 2 objects, you want to get the object from the method that you're testing and then set up your expected object. And when it's a data structure, especially when it's a linked list or a tree, it does get a little tricky. Here it's a hash map. So we're going to create a new hash map and put in that hash map everything that we expect from the file that we're reading in this case. So we're going to add in everything we expect in the way we expect it, everything exactly the way we expect, and then call our utility method. So your only real task, the tough part of writing each test, is setting up your expected, which can be a little bit of work when it's we have a hash map of strings to array list of custom objects. These cities can be a bit much. And there's one big problem with testing like this is I'm loading all the countries in this file to get my actual, and then I have to set up my expected, but my expected is 47,977 different cities. Evening, Patel. So I am not going to set up my test case for that. I'm not going to have enough time. Like I'm just not going to bother. I'm not going to put all of those cities into my test cases. It's just not going to happen. I'm never going to do it. No student's going to do it. And usually when I do see students attempting that, what they'll do is assert that actual is the right size that they expect. They'll say, was actual 49,000, whatever number I just said. 49,000. No, that's not even the case here because it's the number of countries. I am done complete BCA. I don't know what BCA is. Uh, so they'll like check the size or something, but they won't actually check if everything is what they expect it is. The solution to this is don't use cities.csv, man. Don't use it. Don't use songs.csv. Don't use movies.csv. Don't use movie ratings.csv. Don't use these giant files with thousands or tens of thousands of lines of data. That's not feasible. And you're going to shortcut your tests because nobody's writing the test case with all of this data, all this expected data. You're going to take shortcuts. You're just going to check the size of the returned data structure or something, or check like the first value or something. You're not going to check everything. You're just not going to do it. The solution to this is creating smaller test files in the same format as the full data. So my cities.csv has a header, so I'm going to put a header here. And I'm going to start with a test case with just one city. I'm just going to put one city in here. I just have Buffalo in this data file. And then in my testing, I'm only expecting Buffalo. I'm expecting the country US to map to an array list with just one city that has Buffalo in it. That's all I expect. When I'm giving it cities test 1, cities test 1 has one city. I expect that one city. It's easy to create my expected value here. Now I'm making sure that actual contains every single bit of information that I'm expecting. Everything has to be exactly right with that instead of just checking the size or something, some bullshit shortcut that people like to do. But if you're using cities.csv, you really have no choice but to use shortcuts. And then likewise, I created a second test. Obviously, you would want more testing than this, but just to show the example, I want another test, start testing all my different situations. Here I have at least one city with one country with multiple cities and multiple countries overall. These are the types of tests that we want to think of. So when you're using songs.csv, making sure you have like a song that's been rated multiple times, multiple songs that have been rated multiple times. You want to mix it up a bit, but don't put so much data in there that it's very tedious to be able to create your test cases, because that's going to be, I guess I already said it, tedious. Same with your movies.csv. Take a few lines. And one thing I see people missing on movies.csv is they'll take the first two lines. I see a lot of test cases with Toy Story and Jumanji. They'll take the first two lines. They'll create movie test 0.csv. They'll paste these two lines and that's their test case. You don't have to do that. You don't have to do this. Exactly that is, even though some of these people might get mad, but that's their problem, right? We can cut down the cast list too. Let's cut some people out of this. Make sure you have enough so it's a good test case still. So we have one with 2 cast members and one with 3. So we're making sure our code can handle a variable number of cast members still, but we're limiting how much we have to code in our test case. We don't have to copy and paste that whole cast list and format it into an array list and everything. You can cut these down quite a bit. So this is testing with files. When we test with files, we want a small amount of data, at least for our first test case. I always like my first test case to be a sanity check. I'll just put one piece of data in there and then create more test files that have more data in them. And then when we're testing with these, let me close some of these so I can see all my files. And when we're testing with these, our file name, notice that these are all in a data directory. Your files, all your test files have to be in a data directory named exactly data, lowercase data. That directory is already given in your handout, so make sure all of your test files go in this data directory. That's what Autolab's expecting. It's not looking for test files outside of that directory. So make sure all of your test files are in this data directory, and then in your tests, your file names are data slash and then the file name. The paths are always from the root directory of your project when you have file paths in the way IntelliJ runs your programs anyway. It's going to be from this root directory, so I'm looking in data slash test cities, cities test 1. So right here. Then cities test 2, I'm looking for 2 key value pairs, GI mapping to just this one city, and then AE mapping to these 3 cities. I got one more testing note. Let me do it right here, and then we'll get to the live coding. So we saw in this one, I have 2 hash maps, and I'm checking them for all the values that I'm expecting. I have to go through them manually because city doesn't have an equals method. I do have to use my compare cities so I can check all the values of the instance variables instead of the references of the cities. So I do have to go through my hash maps manually, and you will have to go through your array list manually for your task 6. And I do have an example in the repo, which the easiest thing to do is just mirror this example. In week 6, lecture coding bank tests. In the summer, we don't have time. This whole week actually gets cut, this testing tips and tricks week. But this example right here, this bank tests, is the one you want. Check array list of bank accounts. What this will do is exactly the same thing as your task 6 expects you to do, is comparing 2 array lists with references to objects where the objects can appear in any order. So when you're returning your songs, your array list of songs and your array list of movies, they can be in any order. They don't have to follow the order that they appear in the files. So we have 2 array lists that are in any order, and we want to make sure they both have all of the same values, meaning all of their objects, each one has objects that have the same values for their instance variables, and they can be in any order. So what we want to do, first thing we always do, check the size, and then we're going to go through our expected. We can't just go index by index anymore because these things can be in any order. But if we go through the expected, grab the bank account. So for each bank account in our expected, or each object in our expected song, movie, bank account in this example, for each bank account in our expected, we're going to grab that bank account and make sure this bank account exists in our actual. So this bank account, I can't just assert, I can't just go through everything in my actual and assert that it equals this expected account, because that test is always going to fail unless the array list is size 1. It's always going to fail because at least one of your accounts in it, your actual, is going to be isn't going to be that expected account. All but one of them will be. So what we want to do is look through our actual, get our actual bank account, and for each one, check if it's the one we're looking for. And if it's the one we're looking for, it has all of the right values. This is where you would call like a song or movie, compare songs, compare movies helper method, to make sure it has all the right ratings and everything. You don't have to think about that. Just grab the methods that you wrote prior. You do have to combine it with your compare linked list of ratings method, utility method, but you have those methods. You've already written these methods. So use the work that you've already done, compare them, and then say, oh good, we found that one. So I'm using a Boolean flag here. I don't like Boolean flags, but this is one situation where it's just the easiest way to do it. I'm using a Boolean flag. I'm saying I haven't found this yet, but once I do find it, mark it as true. So now I've found that that account that I'm looking for, or that song or that movie that I'm looking for. And then after this loop executes and I've gone through every actual bank account, then I'm going to make sure that I found that value. I'm going to assert that I found it, because if I made it through everything in expected and I didn't find this bank account that I'm expecting, well then it's not in the actual, then the array list that I'm testing. So this will fail and the test will fail as it should. So this is the proper way to check if 2 array lists have all the same values that are in any order. Of course, you can do it in other ways, but I mean, this is covered in lecture. It's in the repo. I would copy this if I were you. If I were taking actually, if I were you, I'd probably rewrite it from scratch just so I get extra practice. But one thing you can do is grab this, copy it, paste it into your code, replace bank account with song or movie, or both. Have two utility methods. And then replace all of this checking to see if two bank accounts are the same. Replace that with your logic to check if two songs are the same or two movies are the same. So this is one of the big challenges with task 6 is how to compare array lists. One of the big things that you're getting experience with, comparing array lists where the order doesn't matter. Because my correct solution is going to return the values in any order, and you just have to check, are these the right values in any given order? Okay, with all that, I only left myself 4 minutes here, but we can finally start writing some code. All right, so I have to return a hash map of strings to array list of cities. I should have left myself a little more time, but I need to say all that stuff. Countries, it's all important for your tests. Test 6. All right, so I'm going to need that hash map of countries. So I'm going to create my hash map and then return it. And in the middle here, I need to populate this hash map with all my values. I'm going to use my read files as a helper method. So read files of file name. That's going to give me an array list of strings. That's going to give me all the lines of the file as an array list of strings. I'm going to call that lines. Read file, not files. And then I'm going to iterate over those strings. So for string line in lines, I'm going to process each line. So here's where I need to do my split. I'm going to do line.split on comma. Oh, my line that I copied isn't in my clipboard anymore. So what I like to do is grab a line from the file that I'm parsing and just paste it in my code just so I have a reference so I can remember what I'm actually working with. So I'm going to split on commas. I'm actually going to add my check right here because I'm running a little low on time. Screw it, I'm going to do it like this. I have a header line for this data, so I do have to handle the header line. Usually I have this as a surprise in lecture, like, oh, the code didn't work. If line, oh my goodness, that would have been a bad mistake, equals this exact line, I'm going to use the keyword continue, which means go to the next iteration of the loop. Just skip this iteration of the loop and go to the next one. So I'm going to split this. Dare I use a string array? No. Let's use an array list of strings, since that's what I showed. String splits, new array list, arrays dot as list, lines dot split. So just from the slides, I want to split this line into its separate parts, and then grab all these parts. So the country is splits.get of 0. The city is splits.get of 1. I'm going to run out of time here. The region is 2. Population Population is an int, so I need to convert this to an int. Integer dot parse int. Double latitude equals double dot parse double. This is 3, 4, longitude 5, and I need a new city. So my city equals new city. I do want to get to this last part. I don't like doing this, but I will go over a little bit today. So I want to make sure we get this. So city, and making sure I keep track of my order, name, region, country. Name, region, country. Population, new location, lat long. Because I'm reusing reusing a variable name there. And then what I want to do is check for two things. I want to make sure I get to this part because it's important for task 6. Is for songs and movie ratings, you're going to have the situation where a song or a movie shows up multiple times in the data, and you have to ask yourself one big question. Have I seen this song or movie, or in our case, country, before? Have I seen it before? And do something different, whether you've seen it before or not. And I actually like doing something called lazy initialization, is I'm going to say, if I've never seen this before, then initialize it. So if I've never seen this country before is the question I have to ask. So if countries dot contains key of country, so this means I've seen the country before. I'm going to put a not in here. This means I've never seen this country before. That means I want to initialize this country. For our case with this hash map, I want to do countries.put the country and then new array list to get that empty array list of cities. This is the very first time I've seen this country. Initialize that array list. And then whether I've seen this country before or not, I'm going to go to countries.get this country. So get the array list for this country and then add this city to it. So it's important if you're always initializing this. So if you're reading a song, you find a song and you just create a new song every single time you see a song, what you're going to get is when you have a file with multiple ratings for a single song, you're only going to get one of those ratings. So you want to make sure you capture all of those ratings into a single song object, and same with movies with movie ratings. You want to make sure you capture them all in the same object. So if you've seen that song before, don't create a new song, just add that rating to the song that already exists with that ID, title, artist. And I recommend doing them by ID. If you create a hash map of ID, song ID as a string to song objects, then you can very quickly, as you're going through the data, check, have I seen a song with this ID before? If I have, grab it from the hash map and then just add this rating to that existing song. But if I haven't seen the song before, create it and add it to the hash map by ID, because the hash map has a really convenient way to just say, does it contain this key? And if that key is the ID of the song, it helps clean up your code a bit. And then at the end, since you have to return an array list of songs, you have to take the values of that hash map and stuff them all into an array list and then return the array list. But you can still work with the hash map. So following this same example here, work with a hash map, and then in the end, take the values of your hash map, which are your songs, and then return those in an array list. And then if we run this just to cap off the lecture, we should hopefully be passing. Yay, we pass. Break our test just to see it fail. fails. That means we are actually testing something, and we're looking good. And 2.5 hour lectures are long, but when I'm stuffing it into an hour, it seems so short now. I wanted more time. I wanted more time. All right, but we are out of time. I went 5 minutes over, unfortunately. I will be in... No, this is the first lecture. So I have the 11 midterm, and then 2 o'clock, 2 to 3, I'll still be in office hours today, if anyone has questions. But, all right, so for me, hopefully y'all did good on the midterm. We'll get those graded as soon as possible to let you know how you did. All right, take care, everybody. Have a good one.